Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site, and this video is all about Boeing 737 freighters. So for the contents of this video, we're going to start off by looking at the various versions of 737 freighters, short discussion on the economics of conversion, then we'll look at the various companies offering conversions and the differences between those, what those companies have to offer. Then on to differences of cargo aircraft from passenger aircraft, a look in detail at the main cargo doors, then into the flight deck for differences you'll find in there. Short discussion on fire and smoke protection, a look at horse freighters, how they differ from regular freighters. Then on to loading and weight and balance considerations, and finally a look at operational differences and documentation. As always, please treat your company training and their manuals as the authoritative source of information. What I would say before I go on is that this presentation is likely to be a fairly lengthy one, so by all means please use the contents list that I've drawn up in the comments here to skip between the different chapters. Obviously the video is intended to be seen in order from start to finish, but if all you want to look at are the flight deck differences or the differences from regular passenger aircraft, then by all means skip to those sections. And the same goes for all of my other videos as well, where the chapter list is there for your convenience for you to use. Okay, so on with the show. Let's look at the different versions of 737 cargo aircraft there have been. First of all, let's get this out of the way. Are they freighter aircraft or cargo aircraft? The terms seem to be interchangeable. In English, English, a freighter will be the aircraft and the cargo is what's carried in it. But the two terms, as I say, do seem to be interchangeable. The reason I raise it is that some cargo 737s have got the suffix C and some have got the suffix F, depending on the model and the converter. I will go through the nomenclature as we come to it later in the presentation. Pure freighters, or all cargo aircraft, they've got the entire passenger deck configured to carry freight and a main cargo door just after door 1 left for pallet loading, so much as you see in this photo here, looking from the front of the cabin down to the back. Combis, now these are a permanent combination of passenger and cargo aircraft. The actual size of the passenger, and therefore the cargo area, is decided at conversion and is then fixed. You can see the photo at the top shows that there's 5 windows worth of passenger seating at the back of that aircraft, and the photo at the bottom shows the view through from the cargo area at the front through to the passenger seats at the back. The cargo area is always at the front of the aircraft because that's where the main cargo door is, so that's where the bulk loading can occur. QCs are quick change, so these are usually used by airlines that do passenger ops with their aircraft during the day and need to convert them into freighters at night for operation at night. The conversion can be done in 30 to 45 minutes with a well-organised team if the seats are pallet mounted. The other kind of aircraft, and this is a photo I had to get from a member of cabin crew from when I flew this, is passenger aircraft that carry cargo. So we used to do these night mail runs with an old airline of mine, British Midland. And what we used to do, we carried passengers during the day. We didn't really do cargo, but we had a mail contract. So we used to carry, I think it was 10 or 15 ton of mail bags up and down the UK at night on certain routes. And what we used to do is we used to basically throw these, we called them hammocks, over the seat backs. So it's the quickest and easiest form of cargo conversion. Takes two people about 10 minutes to do the whole cabin, and you just use a regular passenger aircraft, and you place these fabric hammocks over the seats, and then the team just come on and load mail bags onto them. You know, just throw them on and take them off at the end of the flight. On these, we used to carry a member of cabin crew as a nominated sort of fireman who sat in the back looking out for any signs of smoke or fire. So that's a kind of, you know, hybrid, if you like, cargo aircraft. Okay, just to summarise the main versions, F generally stands for freighter, so that's a generic name for a pure cargo aircraft. C can confusingly either stand for cargo, convertible, which is usually Boeing terminology, or combi, an aircraft which has got a passenger and a cargo area. QCs are quick changes, so they're aircraft that can be quickly, less than an hour, converted back to passenger ops from cargo. Alright, so that's out of the way. We all know what we're talking about now. The very first cargo 737s were actually offered before the first 737 had ever flown, and this document I've scanned from here, which is in my library, is dated November 1966. So that's before the first 737 had even flown. So none of the Boeing built originals were pure freighters. They were all either convertible or quick change, which is why the terminology on here is all 737-100 or 200C. C, you know, covering both C and QC. I say that they offered these actually before this document. The earliest documentation I've seen was in April 1966, so that was a full year before the first flight of the 737, and the first one was delivered to being consolidated in September 68. So they were fairly quick off the mark in ordering and getting one of those, and I believe some of those aircraft are still flying in Canada today. Anyway, despite offering the 737-100, none were ever built in the cargo versions, at least. I mean, very few 100s were ever built anyway. I think there were only about 30 of them built. But as you can see from this document, they were offered. The 200 though was actually quite successful. 96 freighter 737-200s were built by Boeing. Some of those are still in service today, as I say, up in Canada and some other parts of the world. So this is the venerable 200 cargo version. That is probably an ex-Veen consolidated aircraft because they took the option of the retractable rear built-in air stairs, which you can see deployed there. Anyway, the 200C, it's got a 3.4 by 2.18 meter. It's a standard 134 by 87 inch main cargo door. It's standard for that size, so that it can accept an LD7 or AAA size pallet. It's also got strengthened floors for the cargo loading, because you know the weight density is much higher than it is with passengers, and additional seat tracks. The 200 could take 7 full-size pallets, plus loose cargo, of course, in the underfloor holds. Conversion time to passenger configuration was quoted as 3 hours, which I think is quite optimistic on the standard convertible. The QC obviously was a lot less at 45 minutes. The combi option, as we've already mentioned, had pallets at the front, passengers at the rear, separated by a bulkhead, which has got a door in it for cabin crew to go through, you know, pass between the flight deck and the passengers. So the For operators that wants to switch between passenger and freighter roles quickly or frequently, and some airlines did this every evening, Boeing produced the QC. Conversion time, say, reduced from about 3 hours to under an hour. The big difference with the QC is that the seats, floor, carpet, everything on the floor was pallet mounted to enable a quick conversion. Even the aft galley was on a pallet and had quick release water and electrical connections to it. So the whole lot just came out on pallets through the main cargo door, and that realistically allowed the aircraft to be used for both roles, which allowed it to basically earn money round the clock, carrying passengers by day and freight overnight. So it was quite a good aircraft, which is why so many of them were sold. This is a scanner I took from a brochure from Boeing for the convertible, and I just included this. It's a sort of historical anomaly, if you like. But basically, what this is showing is how the hat racks can be folded away, up or down to make space in the cabin for cargo. You couldn't do this now. It just doesn't meet today's regulations, as the hat racks now have got to be contained bins to contain any loose objects from being thrown around in a sudden deceleration. So the construction of them, modern day hat racks doesn't allow them to fold away. But it's a little look back in time there at how things once were. So next up were the classics. Now, surprisingly, Boeing never built a classic freighter. That said, there have been more classics converted into freighters than any other generation of 737. It's just Boeing didn't do it, and it was all done from the second-hand market. Of all the classics, the 400 is the most successful series, as it's got more cabin volume for cargo, as you would expect. If you're going to make a freighter, might as well make a big one. Now, one thing worth mentioning here about the difference between the 300 and the 400 freighters is the main cargo door clearance, and this is a photo of a 300 during loading, and it shows just how close that number one engine nacelle is to the loading equipment. The main cargo door is just 38 inches forward of the engine nacelle. Now, into that, you've got to get, well, in this particular piece of equipment, you've got to get albeit a narrow ladder, you've nevertheless got to get that in there. So it's the scope for damaging the aircraft during the loading and unloading process just by the ground servicing equipment is fairly high. There's slightly more room at 98 inches, so you've got an extra 60 inches there on the 400s, but not enough on the 500s or indeed the 600s, which is why none of those models were ever converted into freighters. So on to the NGs. NGs are now becoming much more popular for freighter conversion than the classics, because, well, of all the same reasons that they became much more popular as passenger aircraft. They got better fuel consumption, payload, and reliability over the classics. And as the NGs are getting older, they're coming down in price as well. The two main offerings are, well, the two only offerings actually, are the 700 and the 800. 700 primarily being done by Pemco and the 800 by IAI. Again, just to mention the 600, like the 500, none of them were ever converted into freighters because of the restricted space between the number one engine and the main cargo door. The 900s, interestingly enough, have never been made into freighters either. Now, a 900 freighter was looked at by Boeing in 2003 for FedEx, but never the project never progressed, and no third parties have ever converted a 900. Now, there's a number of reasons for this. I would guess first and foremost because there are proportionally far fewer 900s in service than 800s. You know, the 800s outnumber 900s by 10 to 1. So there's a lot less sort of passenger service retirement feedstock for conversion. What I also suspect part of the reason could be payload as well. You would tend to sort of wait out before you bulk out on a 900. I don't think it's got quite the same economics of payload as the 800 would have for cargo operations. For passenger operations, it's fine because obviously the weight density is much lower. But I think for cargo, it wouldn't quite be as good as the 800. Pallet space. So the number of pallets that a type can take actually varies slightly depending on, well, obviously the model. So a 700 can take 8 standard AAA pallets and a smaller one behind it. The 800, depending on which conversion it was that was done, and you know who did the conversion and which particular one you went for, can take anywhere between 9 and 11 standard pallets plus a small one behind that. The 900, if it was ever produced, and you know, never say never, then that could take one extra pallet, one extra full-size pallet over an 800. All right, so let's look at the 700C. Now, this was the only Boeing produced cargo 737 from new, other than the 200C. So, as I say, you know, straight from the factory, there's only been this and the 200. All the rest are conversions of you know, used aircraft. The 700C, it's based on the 700 IGW, the increased gross weight version, which, if you remember, if you saw the BBJ video that I produced, the BBJ is from the IGW family, as also is the 737-700 ER. And the ER, the BBJ, and the convertible all have the 700 fuselage and the 800 wings and strengthened gear. To basically get the you know, an economical payload on that. That's what that's all about. Obviously, it's got a main deck cargo door and a new cargo handling system. Passenger layout, 700 can carry 149 passengers. In the cargo config, it can take 18,780 kilos of cargo on, I say, 8 pallets. Given that with that, you get a useful range of just under 2,900 nautical miles. So quite a versatile freighter, the 700. It was launched in '97, so fairly soon after the NG program was launched. But it only actually got 3 civilian customers: Saudi Aramco, Sonair, and Air Algerie, which you saw on the previous slide. Last delivery of those was in 2016. The big sales actually went to the US military, where it's known as the C-40, as per this photo here, and one ended up as a BBJC. But total sales were only 21 of those. Interestingly, if you look at this photo, which was courtesy of Mark McEwen, you can see that the overhead bins, you know, the hat racks and things, are still in place for this. So that's probably the big difference between the convertibles and the pure freighters, is that the roof space, you know, the ceiling space is more restricted on these. You don't have the full ceiling height. There is a quick change option. Again, you know, it's pallet mounted seats. This reduces the conversion time from 5 hours on the 700 down to about an hour. As previously mentioned, and as you can see in this photo, the ceiling, sidewalls, and overhead bins remain in the interior when the aircraft is both configured and used for cargo operations. Right, onto the 800. This is really becoming the main player now, as the classics start to decline, and air freight's ramping up. This is where the money's going. It's much more popular than the 700 for cargo, simply because of its better payload. 23,950 compared to 18,787 is around about, well, it's just over 5 tons more payload on an 800 than a 700, and being longer, it can take 3 more standard pallets. Again, just to reiterate, these are only available as conversions from passenger aircraft. No 800s were ever built as freighters from new. The only new freighters ever built were the 200 and the 700. Max freighters, these are a long way off. There are no plans for Max freighters yet, either new or converted, and this is simply due to economics. The Max is still young, and it can earn a whole lot more as a passenger aircraft than it ever could as a freighter. Also, there's just no second-hand Maxes on the market for conversion yet. I mean, there's I think it's just short of a 3,000 aircraft backlog on the Max at the moment, so there's certainly none going to become available for freighters. I would estimate within at least a decade, if not 15 years or so. So we've mentioned the economics of passenger versus cargo aircraft. Let's just have a quick look at that, and hopefully we can work out why cargo aircraft are all generally older than passenger ones. So, as we've already seen, cargo aircraft are very rarely manufactured new straight off the production line. There were 90 odd 200s and about 20 odd 700s out of 15,000 737s. So it's a tiny minority that were ever made new. Usually what happens is they operate as passenger aircraft for 10 or 20 years before being converted into a freighter. Why is that? Because they can earn more money flying passengers than freight. And why is that? Because passenger flying is much more intensive. It's more round the clock. It can be 24/7. Depending what airline you work for. Fortunately, I haven't had to fly for one of those. But freighters typically only fly about maybe 4 hours a day, or 4 hours a night, I should say, for 5 days a week. There's very little freight movement at the weekend. It's mostly midweek, mostly in the middle of the night. Passenger aircraft, though, they work from, well, I don't need to tell you what your rosters are like, but early shift can start around about 5-6 in the morning, and you can be flying up until 3 the following morning. So the passenger aircraft will put in at least 10 hours a day, often more, 7 days a week. So they give better returns for the money, because they're simply doing more flying. Because of that, demand is higher. And so the leasing costs, or purchase price, outright purchase price for 737s are higher on those aircraft. So let's have a quick chat about leasing costs. In case you don't know, very few airliners are owned outright by the airline. Usually what happens is an airline may place an order with the manufacturer, and they may even buy it from the manufacturer. But certainly the airlines I've worked for, what happens is you do this sort of sell and leaseback process. So you buy the aircraft from Boeing, then immediately, before you've even taken delivery of it, you sell it to a leasing company like, I know, GCAS or whoever, and they then lease it back to you. So why is that done? Because airlines just don't have the amount of money in the coffers to buy a fleet of aircraft outright. So they lease. Same as you might do with a car, depending on your financial situation. Most aircraft are leased. As the aircraft get older, their leasing costs, or the outright purchase price drops. When it reaches a figure that the freight market will sustain, again going back to the previous slide, that freight margins are tighter than passenger margins, then the aircraft get converted into freighters. And to put some numbers on it, a new passenger aircraft leasing costs, and again these are approximate because obviously the airlines don't like to talk about these figures and they cut deals, so there's a huge variation in these leasing costs. If you're leasing 200 aircraft off a lessor, then you will get a far better rate than this than if you're only leasing one or two. But say it's $450,000 a month for a brand new aircraft straight off the production line. By the time you've put 7 years on that, the leasing cost might be down to $300k per month. By the time it's 15 years old, it might be down to say $180k a month. That's the kind of point when it can start to break even as a freighter. Now that point's been coming forward in recent years as e-commerce has taken off and aircraft are being taken out of long-term storage. The deserts are emptying, not to put them back as passenger aircraft, although obviously post-COVID that was the case, but ignoring the COVID anomaly, older aircraft were put into the desert, waiting to be either scrapped, parted out, or some very low-cost airline coming up and snapping them up. But what's been happening in recent years, say with e-commerce taking off, is they've been getting pulled out of the desert and being converted into freighters. Now when that storage stock dries up, when the deserts are empty, then freighters will become more expensive as the in-service passenger aircraft then are the only ones left to be converted. So there's where the leasing cost can start to change again. As regards suitability for conversion, Mike Andrews, who's Director of Conversions at Pemco, said back in 2017 that when it comes to conversion, we look for an airframe with relatively fewer cycles than normal. He said with a 737 having a lifespan of about 70,000 cycles, we look for a sweet spot of around 35,000 that gives the aircraft a good life as a freighter. Now, there's a huge difference between what you want in life and what you get in life, and those aircraft are probably all gone. So it's a nice aspiration, and I'm sure it was true in 2017, but certainly as regards classics, they will all have been snapped up by now. So converters are going to have to start to look at higher cycle aircraft, which will have an associated impact on the market value. So it cuts into the margins for conversion costs. But there's an argument to be said that you can buy a high cycle, high hour aircraft for freight, and it won't be a problem because, as previously said, when you run it for freight, you're only going to be putting 4 hours a day on it, and maybe 2 cycles. So it's going to be convert from a high hour, high cycle aircraft to a relatively low hour, low cycle aircraft over the course of its life as a freighter. So swings and roundabouts, lots of things to consider, but these are some of the factors in the in freighter conversions. Demand for freighters, well, you see in this photo that a pal of mine took, he said the entire aircraft is usually these days, certainly on the ones he flies, it's just full of Amazon boxes. That's all you can see. And it's currently estimated that express freight powered by e-commerce, so this could be Amazon, eBay, whatever it might be. It's projected to grow at 5.5% over 5 or 6 years, which is significantly faster than general cargo, and this is what's leading to a larger global fleet of freighter aircraft. There were 110 narrow-body conversions in 2022, and that was more than double the annual output during the previous decade. So that gives you an idea of how it's all ramping up. Conversion facilities say they're booked up for over 2 years ahead, and they're opening more new production lines all around the world. On almost a monthly basis, to be honest, between all the converters. So we've spoken about leasing costs, but let's just have a look at the outright cost of a freighter. You can buy a 20-year-old used 737-800 for around about $50 million, give or take. The P2F, passenger to freighter conversion, that's around about the 3.7 million mark. You will probably want to do a C check on it then, the heavy maintenance check, because that's probably going to be due, and it's a good time to do it while you've got the aircraft stripped apart. And in actual fact, it's probably going to be part of the reason why the aircraft became available and came onto the market anyway, that the C check was coming up. So it's a great time, either end of lease or conversion to a freighter is the perfect time to do a C check. So for about 20 million, you've got a converter freighter, whereas the cost of a late, bill, say 5 to 10-year-old 800, it's over twice that amount. So it actually makes good economic sense to convert to a freighter. There are most of the aircraft being converted at the moment are 737-800s. At the moment, there are 121, again, give or take. It's probably slightly above that now. Active aircraft, 47 pending conversions, and I would say that number's definitely gone up. That's probably nearer three figures now. And the 33 in storage, again, I compiled this data 6 months ago. I would say that there will be less than half of that in storage. Compare that to just 10 A321Fs and around 250 757 freighters. Now, you can talk about how good this comparison is. There are a number of reasons for it. The 757 was the go-to narrow-body freighter. It was perfect for it. It was such an overpowered aircraft. The payload was amazing. They are starting to get a little bit long in the tooth, and in all probability, the A321 will take over from where the 757 left off. Just a shame Boeing didn't re-engine the 757, but there we go. Anyhow, the number of conversion lines is growing very quickly. Some experts are believing that the risk is too much feedstock going through could quickly result in an oversupply. Personally, I'm not sure that will happen against the backdrop of softening demand for air freight. Again, that's the bit I don't think will happen. I think we're all too used to ordering stuff online and wanting it yesterday. That came even more into focus in COVID, where we couldn't go out and shop. The online shopping is really where it's at. Oversupply could result in a reduction of aircraft values and lease rates. Yes, it could. I personally don't think that will happen unless there's a huge global recession, which of course is possible. Okay, so on to the actual converters themselves. Who's doing it? Until recently, conversion from passenger to freighter was always done by a third-party cargo conversion specialist. The only players for the 737 were the three on the right there: Pemco, IAI, and BDEC. They've been doing conversions for decades. Absolutely decades, from the 200 through to all the classics, and now the NGs. Coming very late to the party were Boeing, who offered the BCF, the Boeing Converter Freighter, in I think the first one of those was delivered in 2018. They realised what a lucrative market it was, and decided they wanted a slice of the action. So let's look at them one by one. Pemco, who are now officially known as ATSG. They were the first converter to the 737, and that was a 200. I don't know when that was. It was probably early 80s. But the first classic conversion was back in 1991 for a French company called L'Aéropostale. They offer a selection of 4 variants of known as the FC, QC, and Combi on the 3, 4, and 700. 700 starting in 2020. They've got conversion lines in Florida, Costa Rica, Canada and China, and probably more opening up as we speak. The spec for the 700 is over there on the right. So Pemco are, I think, the only ones doing the IAI doing the 700 as well. Well, Pemco have kind of got the 700 sewn up, to be honest. According to Pemco, their conversions provide the highest weights and volumes available due to the use of OEM, that's original equipment manufacturer data, together with high quality engineering design and floor beam reinforcement, results in industry's highest allowable running loads and highest total payload without frequent revenue robbing floor beam inspection intervals like other STCs. So there you go. So that's their selling point, is OEM data and a very strong floor beam. AEI, who are the other big players, again also based in the States, they've converted over 200 737s, which is really impressive. The first 737-200s were done in '93. They've done 150 classics and 37 800s. And they were the first company to offer the 737NG conversion. So AEI tends to focus now on the 800, and Pemco focuses on the 700. They both still do classics for those that want them converting, but those numbers are starting to dwindle. AEI suffix is SF. So any of their aircraft which have been converted, or any aircraft you see as a 400 or an 800 or even a 200 SF, it's done by AEI. So they delivered 31 800 SFs and just 5 classics in 2022. So you can see all the actions with the NGs at the moment. AEI's big selling point, compared to our 737-400 conversion, we change all the floor beams after the wing box because it's a cleaner, faster solution than the one we employed on the classics. Otherwise, the conversion is similar. Great quote from Bob Convey from AEI, said, "The freighters like pickup trucks. You want them simple and reliable, especially a converted narrow body." Love that quote. They've got conversion lines in Florida, Alabama, Canada and China, both with Stako and Heiko. Conversion running between 100 and 120 days, depending how it goes, what maintenance work you want to integrate into the job as well. And the specs for the 800 conversion are as shown on there, and that's just straight data from the AEI website. AEI is currently the only conversion company to have ETOPS 180 approval on the 800 freighter conversion. It can convert all 800 line number aircraft, including those with a flat aft pressure bulkhead, split scimitar winglet, but not non-winglet aircraft. So almost all 800s it can do. There are very few of the early ones, and that's again just a wing loading issue with the weight. AEI's conversion cost is roughly $2 million less than Boeing's BCF, so that's another selling point for AEI. IAI BDEC, you may not have heard of them, but they are around. They're a good steady producer of conversions. They're based out in Tel Aviv, and their first conversion was for the American market, this one here, Kitty Hawk Air Cargo, and that was a 300 and delivered way back in April 2005. Their first 400 was delivered in 2009. Now they don't do classics anymore. They only convert the 700 and the 800. All aircraft converted by IAI have got the suffix BDSF, which stands for BDEC Special Freighter. The stats and specifications for the BDSF 700 and 800 series are shown there. So payload is really the headline figure: 41,500 pounds on the 700 and 53,000 pounds on the 800. Notice on the on the main deck loading configurations down at the bottom of the screen, particularly you can see it on the 700, there are various different configurations for, well, they're 8, 9 or 10 pallet positions, similar on the 800 as well. So that there are, well, you can see there are 4 different configurations for the 800. I'll come on to, you know, how many pallets can an aircraft hold later, but if you just keep this in your back of mind, the answer is not clear cut or straightforward. It's, you know, it's variable depending what you as the customer want. Okay, and then Boeing's BCF, Boeing Converted Freighter. I say surprising latecomer to the market. The first one was completed in April 2018 and delivered to West Atlantic, who proudly sport the first 800 Boeing Converted Freighter logo on the tail. Boeing said that for the first time, operators get one-stop shop support through the life cycle of a standard body freighter, originally manufactured by Boeing, converted by Boeing, and supported by Boeing. And this really is Boeing's big selling point, is that it's all, you know, in-house. It's the support. Conversion lines are in Gatwick, Costa Rica, and China. There are 15 lines at those 3 conversion centres through, say, in-house P2F facilities and through a network of partners. As I say, the big selling point for Boeing is support. This, as they say, includes fully integrated manuals accessible through MBF, which is My Boeing Fleet. So this is the portal where we get all the documentation, everything from FCOMs and QRHs and AFMs to all the maintenance manuals, wiring diagram manuals, you know, everything. It's all in one place, rather than in separate manuals which are written by the STC, you know, manufacturers. So separate manuals written by, you know, AAI or IAI or Pemco or whoever. You got spare parts commonality with production freighters as well. Data there, again, the only one I've highlighted is the payload. That's the max structural limit payload there of 23,950 kilos. The volume limit payload, which is a couple of lines above, is which is the more realistic figure, is 2768. So, summarising all of those as best I could, I put together this little table showing the difference between the various converters. I won't go through it. It's there. You can pause the video there and read that in your own time. Summarising the nomenclature, so for the 700s, there have been Cs, which are convertibles. They're the new ones from, you know, as built by Boeing, the IGW aircraft with 700 fuselage and 800 wings. QCs are quick change, so pallet mounted seat version. C40, A, B and C is the US Navy, what they call the 700C, and the BBJC was basically a one-off BBJ. Which was a convertible. Regular 700s, you got the Fs, which are done by Pemco, the FCs, or the Flex Combi, done by Pemco, and the BDSFs, which are done by IAI BDEC. 800s, SFs by AAI, BDSF, BDEC, and BCF, Boeing Converted Freighter, are by Boeing. So all a bit complicated, but that's me trying to rationalise it all for you there. All right, on to the differences. This is a great graphic from AEI, and that is kind of a summary of all of the main differences between a cargo aircraft and a passenger aircraft. So these are the changes that are done during conversion. Rather than go through it all on this one busy slide, I'll take you through the main parts now. So the main cabin. This photo is actually of a 200, but it doesn't really matter. I mean, as far as the cabin goes, it's empty. The seats, the overhead passenger panels, lights, call bells, PSUs, loudspeakers, air vents, all of that stuff that's normally over your seat when you sat in as a passenger, all that's gone. The aft galley's gone, the aft toilets are gone, all removed for space and weight savings and for simplicity. There's less stuff to go wrong. So all the pipe work's taken out, from the aft toilets through to the front. On permanent freighters, not convertibles or quick changes, the passenger windows are normally blanked by replacing them with lightweight aluminium plugs. So this one, well, it's a 200, so they were all convertibles. So that's why the windows aren't blanked. Although not all conversions, particularly the early ones, did that. In front of the main cabin is what's known as the supernumerary area. Now, these are quite different from each converter, and they're also different from generations. So a 300 by AEI will look different to an 800 by AEI in the supernumerary area. This actually is an AEI one, so this is from an 800 SF, and you can see that there are 5 supernumerary seats as standard. The galley's still in place there, so they can brew up, or more importantly, make a brew for the pilots, and the forward lav's still there. Obviously, you do need one of those. This photo here is the BCF, Boeing supernumerary area. And you can see that rather than 3 luxurious almost passenger type seats, you got 4 fold away crew type jump seats, rather than the nice big ones. So I guess it's space saving and what have you. The maximum number of supernumeraries may be reduced from 4 or 5 or what have you free tops operations. So again, check your FCOM and your AFM for details about that. But what I'm saying here is, just because there are 4 or 5 seats there doesn't mean to say that's how many you can take, because if you're operating an ETOPS flight, it may be less. More about main cabin occupancy. There's a dispensation from the applicable CFRs to carry the applicable number of non-crew members. Now these people could be special couriers for cargo which is either valuable, confidential, fragile, perishable or hazardous, or they may be livestock handlers. Now there's a full list of this well, the reference is there, CFR 121-583, sections 1 to 7, and that is often placarded somewhere on the aircraft. Each supernumerary must have portable oxygen available in case they need to enter the cargo area during flight. You're not allowed in there during flight without portable oxygen. The supernumeraries have their own information panel or lights or chime system, so oral or visual systems. They're available for supernumeraries, and the cases that they needed for are decompression, oxygen masks on, fire and fasten belts. And again, depending what aircraft you're in, I mean the BCF photo there on the left, an AEI Classic there on the right. And those of you flying a mixed fleet, you'll know when you go on. It's almost a case of hunt the signs, to try and find out where they are. But they'll be there somewhere which should be prominent and easily visible to the supernumeraries. The BCF has got a system called MDAS, and depending which document you read, the maintenance manual says that MDAS stands for Main Deck Access Signaling System. The FCOMs, it's Main Deck Alerting System. Anyway, whatever it is, we know what it does. It uses the main deck cargo ceiling lights and warning horns to signal to the main deck occupants to return to the supernumerary area. Okay, let me take you through the various functions and meanings. So the first one is in turbulence. In turbulence, we in the front, we'd switch the seatbelt signs on. On a regular passenger aircraft, that would just switch the fasten belts on. On a BCF aircraft, it will cause the main ceiling the main deck ceiling lights to flash on and off for 30 seconds. So that is a visual signal to the supernumeraries to go back to the seats, well, back into the supernumerary area if they're in the cargo area, back into the seats and strap in. If smoke is detected, then the main deck cargo compartment warning horns will sound for 10 seconds and the main deck ceiling lights will flash on and off for 30 seconds. This is an automatic function. It comes straight from the cargo panel. We don't need to do anything for this. If smoke is detected, this will happen automatically. The warning horns will sound and the lights will flash. If the cabin altitude reaches 14,000 feet, again, automatically the main deck cargo compartment warning horns will sound for 10 seconds and the ceiling lights will flash on and off for 30 seconds again. And the final one is the don oxygen stroke return to seat. So if we were to switch the passenger oxygen switch on the overhead panel on, this will manually start the main deck cargo compartment warning horns to sound for 10 seconds and the ceiling lights will flash on and off for 30 seconds. Now you could argue there's a duplication between that and the pressurization. Well, yes, there is, but the idea is that you do this before the cabin reaches 14,000 feet if you see a depressurization taking place. If you don't catch it, the aircraft will automatically catch it at 14,000 feet for you. Okay, so that's the MDAS system. The alarms that I spoke about, there are 4 of them there in the main deck cargo compartment in the ceiling. They're those little sort of black circular objects. There's another one in the supernumerary cabin as well. I've got a photo of that later on. Those main deck cargo ceiling lights are also part of the MDAS system. Don't forget, they are the ones that will flash on and off for 30 seconds. Oh, there you go. That's the supernumerary area MDAS oral alarm. So, passenger oxygen and signs. Again, most freighters don't carry passengers, but they do carry supernumeraries. The passenger oxygen in this context is taken to mean the drop-down oxygen mask and don oxygen signs if installed for supernumeraries. So it's either drop-down or the portable oxygen. Some modifications, for instance Pemco, they've got drop-down oxygen masks above the jump seats in the forward vestibule, so the passenger oxygen switch will drop those down. Others have just got drop-down oxygen masks in the lav, and on those aircraft you have to use portable oxygen. The standard flight deck oxygen panel is installed on all conversions, regardless of whether drop-down oxygen is fitted or not. So it triggers the sign. It tells the supernumeraries to put oxygen on. It may not drop, a standard rubber jungle as would happen on a passenger aircraft, but the sign is there. What it's doing is it's just telling them to put oxygen on. And as previously mentioned on the BCF, that switch is wired into the MDAS system. Crew oxygen on the BCF, you got 2 115 cubic foot oxygen bottles on the 800 BCF. They are located just after door 1 left on the 9G bulkhead, as you can see there. They supply oxygen for the flight deck as well as for any supernumeraries in the supernumerary area. All of the jump seats are fitted with flight crew style quick donning masks, and the oxygen gauge on the aft overhead panel, so the one way up above your head, that indicates the quantity of oxygen for the flight crew and any supernumerary passengers. On the classics, each jump seat has got its own dedicated mask and portable oxygen bottle generated depending on the fit. Located just above the floor level there in this photo here. For AEI Classics, there's a second oxygen bottle in the forward hold, and they're connected together. Both of those are for the flight deck only, so that's a difference between the AEI Classics and the BCF. So, but the second bottle's for flight deck only on those. Again, this is illustrative of the confusion. If you're flying a mixed fleet of freighters from various different converters, there's a lot of different things, a lot of subtle differences to keep on top of, especially if you're flying both generations as well. There are so many different combinations that it does make it quite demanding to know exactly how the aircraft is set up. On AEI conversions, there's an escape rope for exit from door 1 left. That's instead of having a slide. It's actually surprising to see how much lighter the door is to operate without the slide fitted. Other conversions keep the slides on doors one left and one right, so they don't need the escape ropes. Fairly rare thing to have the escape ropes, but it is there on some aircraft. Certainly, if you haven't got the slide bustle, then you need to be looking for the rope. Some aircraft with escape ropes have also got a red hook that you can just see there circled at the top forward corner of door 1 right. That's an anchor point, so that the single escape rope can also be hooked over that and used to escape from that side. Again, most aircraft with escape ropes don't have the hook and only have the facility to use the rope through door 1 left. I guess it all depends which way you want to go out, where the hazard is, if there's a fire on one side or the other, or if the aircraft's actually, come to rest on one side versus the other. But as I say, at least that hook gives you the option to use the rope out of either door. Alright, so behind the supernumerary area, you've got the 9G barrier. Now, on early aircraft, and by that I mean 200s and some classics, the barrier was a net, like you see in this photo here. And what it's for is basically it's to prevent the load in the main cargo deck from moving forward into the flight deck during a high deceleration event. That will be a rejected takeoff. Heaven forbid it's an impact of some sort, but it could be. Whatever the decel is, this barrier will stop it, and as clues in the name, it's good for a deceleration of up to 9G. The net ones are made from high strength nylon webbing. That net hooks onto 24 shackles around the floor, walls and ceilings of the cabin. I mean, if you look at it, it reminds me of a spider's web, and I'm sure that the idea was copied from that. I mean, if you want anything doing properly, look to nature. They've designed these things, and millions more years of refinement in their designs. Spiders' webs look like that. It's a great thing to copy for strength. Anyway, nets have mostly been replaced by a permanent rigid barrier, but they're still used on QC aircraft, or which need to quickly convert the cabin for freight operations. So they are still around. The net barrier has been replaced by and large by these rigid barriers, and the huge, well, there's two big advantages of them. One is that they don't distort when under load. So if you have a 9G event or less, the net will distort, as the load goes into it. This won't. This is pretty solid, and that allows the couriers or supernumeraries to sit in front of that barrier. So it makes that space in front of the barrier usable. It's about 4.5 inches thick, depending on which conversion you've got. And the other big advantage of it over the net is that it acts as a smoke barrier when the door's closed, obviously. So there should be a placard there for couriers to keep the door closed unless accessing the cargo area, and of course, in the event of a fire. The maximum rated cargo deck load is marked on the barrier. You can see it there in that picture. That one's what's that, 26 over. So that's going to be a classic. For the 800 BCF, you're up at 53,000 pounds, which is the maximum load you can have in the main cargo deck, based on what that rigid barrier will withstand. Okay, vent panels are these are sort of decompression vent panels, blowout panels, whatever you want to call them. There are some in the rigid barrier. You can see them marked there with the with the black and yellow tape around them, 3 of them in that particular conversion. And they're to equalise the pressure between the supernumerary area and the main cargo compartment in the event of a rapid depressurisation. There's also 1 or 2 vent panels in the main cargo area floor that vents down to the cargo hold. I think there's 1 per hold actually. These vent panels are similar in function, but obviously much smaller to those in the flight deck doors and not required for egress. You know, you're never going to go out through the vent panel. And they can be either hinged panels, as per those in the upper photo in the rigid barrier, or grills, as you see there in the vents down to the cargo hold. The decompression door. This is the door from the supernumerary area to the cargo area. On the BCF, it's much smaller than other conversions. You know, if you look at it there in the photo, you can see it's about waist height, whereas in the previous rigid barrier photos I've shown you, you know, it's sort of shoulder height. The intention here is clearly that it shouldn't be routinely used for access between the areas. You're certainly not allowed to use it during taxi, takeoff and landing, and if you go through the door in flight, assuming there's room, because you know the fully laden pallet, there is only inches of space, but if you've got smaller pallets, you know, you might be able to, but if you go through, then you have to carry portable oxygen, yeah, that's just a legal requirement, because there's no drop-down oxygen masks there, obviously, in the main cabin. So this is called a decompression door, and it serves the same purpose as the vent panels on the other conversions. The main deck floor, the beams in the cargo area, they're reinforced by adding straps to the upper and lower cords. That gives a greater weight loading than would be expected with passengers. And so this photo is from, I think it's, can't remember now whether it's Pemco or IAI, but all the converters do it to some extent or other, because you know, freight has just got a higher weight density than passengers. Floor locks above the floor. These are at certain locations in the floor to stop the containers moving around in flight. So these are what you use to lock the containers in place. If you don't, they could, you know, move around in flight, you know, with changes in deck attitude or indeed acceleration or deceleration. So they could create an out of trim condition. They shouldn't breach the 9G barrier though. Note of caution here, beware that floor locks look similar when they're up and not locked from when they're just up and locked. It's quite a subtle difference. You can see on the photo there there's just a little yellow sort of area to catch your eye. So worth checking these wherever possible. And there's a photo of one in the up and locked position. So they just bite the lip of the container to hold it in place, stop it moving around. The aft container position is narrower. So this photo is taken right from the back of the aircraft, and you can see that there's a white rail on the floor, and that is to allow pallets of narrower dimensions, typically 53 by 88 inches, to be loaded into that aft container position because the fuselage tapers, so you can't fit a full width pallet into that position. The ceiling, again, differences. I've already touched on these, but I'll show you in particular this one. This is the BCF ceiling. So what you've got there, at the top of the picture, you've got a cabin air outlet. So you know the cabin is still, you know, air conditioned, and of course it's still pressurized. So you know the air for this comes through there. You've got no less than 24 smoke detectors in the main cabin. They're those things. They look a bit like speakers, but they're actually smoke detectors. If in doubt, there's a placard next to them, a caution placard telling you not to cover them. Lots of lights down there. Again, they form part of the MDAS system, and 4 warning horns, which are also part of the MDAS system. The ceiling height is raised to 84.5 inches, which is higher than a standard 737 cabin. So you'll notice it when if you ever go onto a freighter that the ceiling is much higher. You lose a little bit of floor room by the roller system that's added on, but you gain it on the ceiling, and that's done by removing overhead lockers, sidewall risers, the environmental ducting, and that maximizes the space for containers, and also keeps the necessary minimum 1-inch air gap between the top of any cargo and the smoke detectors. So that extra headroom is quite useful. Now, the fuselage, as I've already mentioned, tapers to the aft container position, and to get the necessary ceiling height there to enable that aft part to be used as for another container, the flight data recorder, which is normally located above the ceiling in the aft galley area, and for a photo where it normally is, have a look at my CVR FDR video. It's been moved, so it's actually relocated to behind the rear bulkhead of the main deck cargo compartment, and you can just see it in this photo here. So it's still in a safe location, the most survivable location near the back of the aircraft, and it's well and truly bolted onto that bulkhead there, so it'll stay with the aircraft and not be ejected out in the event of an accident, which obviously helps finding it much easier for accident investigators. Floor drains are another difference from the cargo to passenger aircraft. So the 2 drain pans in the cabin floor, one near the front, the other near the back. Each drain pan runs the full width of the cabin, and any water is piped away to either the forward or the aft drain mast. If these weren't here and there was any liquid spillage, then that liquid could move about and cause the aircraft to go out of balance. So it is a risk, and hence these drain pans here. That one's obviously the front of the aircraft, because you can see the way through to the supernumerary area. There's also a forward dam installed on the forward side of the 9G barrier, and an aft dam on the aft bulkhead location in the floor panels. And the floorboards are sealed on freighters, unlike passenger ones in which only the wet areas are sealed, which again is more of a reason why you need a drain pan, because I say that if they're sealed, there's nowhere else for the water to go but into these drain pans. Okay, the aft cabin doors. These are all deactivated on cargo aircraft. They're of no use whatsoever. They're inaccessible to crew. We obviously don't have passengers needing to use them. So they're deactivated. The slide is removed because the bus will take up space and be prone to damage or accidental deployment. Some doors have the handle covered as per the BCF on the right photo, and some have got the handle completely removed as per that 200C. So that they're both original doors. Obviously the 200C was done new at build, hence I guess why there was no provision for a handle, and the BCF on the right was a conversion. I was surprised actually the BCF didn't actually remove that handle, but anyway, there it is. They didn't. It's still it's just got those straps over it, so you can't deploy it from the outside. On some conversions, the aft entry and service doors remain visible from the cabin. On others, such as the BCF, the doors are covered internally. So the BCF on the left photo, you can't see from the inside where the doors will be. On the example in the right-hand photo, which is AI, the door's still there. but obviously the slide isn't there, so as previously explained. Okay, the main cargo doors. These are the big difference. Various names: main cargo door, main deck cargo door, or side cargo door. It's all the same thing. It's got to be large enough to take a standard AAA or AAI ULD pallet. That's 88 by 125 by 82 inches. If it can't take a standard pallet, it's no use. The doors are hydraulically powered, and the hydraulic source, control panel and locking mechanism varies from version to version, and I'll go through those with you, but they're all different, which is a pain. They're also different between series as well, between generations, sorry. So let's have a look at the components. This is an AING main cargo door. As I say, they all vary slightly with each converter and even each generation, but they've all got the same basic components. So you can see the big actuators there at the bottom. It's got lights, it's got a vent door and hooks and a torque tube to engage the hooks into the latches. Lights there, little pleasing nighttime shot showing those. I'm not sure how effective they are, but they're certainly better than nothing. Usually, you know, the cargo aprons are reasonably well floodlit, but if not, you've got those in the door. The precise location of the lights, again, like everything else, varies with who did the conversion and which generation it was. The actuators, these are really big bits of kit, very powerful things. Usually two of those near the top of the door, and they usually use System A, but some do use a standalone hydraulic system. The IAI conversion uses a single actuator at the aft end of the main cargo door. These are the hooks. So there's 8 of those along the bottom edge. They grab and lock onto latches which are along the edge of the door sill to keep the thing, you know, locked in place. There's the pistons visible on this. This is an AEI conversion. That's the torque tube actuator. So that piston turns the torque tube that rotates those hooks into the latches for locking and unlocking. When the cargo door is closed, a mechanically actuated sequence valve opens, and that allows hydraulic pressure to actuate the latch cylinders, which drive latch pins into fittings on the door sill. When the latch pins are fully seated, mechanical spring-loaded locks engage lock mounts on the latch shaft. That secures the latches to prevent inadvertent unlatching. And you can see the hooks and the latches in that photo there. Okay, so just a short video showing the closing, latching and locking of the cargo door. So inspection windows, once the door is locked, positive locking of the door can be verified from the ground or indeed from the inside of the aircraft if it's accessible by looking at the inspection windows on the lower edge of the door. When a door is locked, you get a green bar in the windows. When not locked, it'll be a red bar. And again, these vary from conversion to conversion. The AEI conversions have got a torque tube viewport as well, and 2 lock pin viewports on the main cargo deck. On the cargo door. The yellow and black flag in the torque tube viewport means that the door is locked, and these lock pins should be visible through the latches in the lock pin viewport. On the BCF, again, slightly different. You've got a yellow circle in the inspection window when the main cargo door is locked and latched. As you can see from these photos, I mean, I've taken a photo there of safe and unsafe. from the ground and at night, it can be a bit tricky to tell if that bar is visible or not on all conversion types. Some it's easier than others. Obviously, it's worth taking the time just to check that everything is safe. On the AI NGs, the inspection windows are there. It's another variation of the many slightly different arrangements. And on the 200C, it's different again. The 200C uniquely has got a manual locking and unlocking handle, usually flush mounted on the outside of the door, which is accessible from the forward entryway. Door one left. And there's a control panel on the bulkhead adjacent to that entryway there. But that's a photo of that manual unlocking handle in the open position there. Bottom of the door, you got 8 latch hooks, which pull it closed and latch the pins to the latches. Access panels along the outside, so in an emergency, if the system malfunctioning, the engineers can just open these access panels and manually unlatch the door. And you've got viewing windows just below the access panels. No vent doors on the 200. They didn't have them. So a word about vent doors. On classics and NGs, and I say not the 200s, you've got these inward opening vent doors. And the upper photo there shows them closed, and the lower photo shows them open. And these are to prevent pressurization of the aircraft in the event that the main cargo door isn't fully closed, latched, and locked. So it's just a mechanical lever. So when the door is closed, latched, and locked, the vent doors will close, enabling pressurization. If it's not, the vent doors will be open. All the classics had 2 vent doors, and all the NG conversions have just got a single vent door. I say originals didn't have any. The classic vent doors are manually operated. They use a handle on the forward edge of the door. It's got to be opened before the door can be unlocked, and closed after the door is fully closed and locked. All the instructions are usually there on decals if they haven't worn away. And the arrangement of the vent doors is different from every conversion, and it's actually quite a neat way of identifying, a neat and obvious way, I suppose, of identifying who did the conversion. So this is a Pemco. So you got 2 vent doors at the bottom of the main cargo door. This one's an AEI, so they're vertically centered on the main cargo door, so they're not at the bottom, they're halfway up, sort of in line with the passenger windows. And this one's an IAI, where the sort of 2, letterbox shaped, slit vent doors toward the rear of the cargo door. So they're your 3 combinations for classics, depending on who did the conversion. The NGs, and in this case a BCF, they've all got a single vent door. I say that's the vent door on the BCF there. From the inside, you can see it. Open and close. I say, it's just got that cage around it to prevent it, anything fouling it and from it operating correctly. Okay, onto the panel, and again, these are all completely different for each converter. I mean, they've got the similar basic functions, but you'd be surprised how different they could be. So this is a Pemco Classic, and depending which conversion it was with a Pemco, it can either be a standalone hydraulic system or the existing B system. But that's the control panel for that. If AC electrical power is not available to pressurize the B system, then the main cargo door can be opened or closed using a hand pump in the wheel well. Heaven forbid. I guess that would only be if the APU was in op and you didn't have ground power. Then I'm also guessing that would be the FO's job to go down there into the wheel well and turn the appropriate valves, which you can see on the left-hand side of the photo. I mean, it's unbelievably complicated, but valves 1 and 2 must be closed, and valves 6 and 7 must be opened, and then select open or closed on valve 8, and then operate the hand pump. I mean, really, I think I'd be calling for an engineer to do it if I ever had to do that for real. But there you go. That's it, and that lot's in the wheel well. The AEI main cargo door panel, as you can see, looks completely different from the Pemco one. It's got the same basic controls, so it's got a master switch, door open and close, and a switch for the floodlights. It's just laid out completely differently. It's also got an extra warning light to differentiate between latches and hooks unlocked, which is a feature that the Pemco panel didn't have. To close it, you hold the door control switch to the closed position. When it reaches the closed position, the main cargo door not closed annunciator should extinguish. When it reaches the full down position, the torque tube rotates. The latch hooks move onto the spools over center, pull the cargo down into the latch position, and that will extinguish the hooks unlocked and the latches unlocked annunciators. The gang bar annunciator then comes next. That pushes the latch lock pins into place in all the latches. That will extinguish the latch lock pins not engaged annunciator, and then it'll close the 2 vent doors, which extinguishes the vent door open annunciator. Sequence of lights for extinguishing is 5, 4, 3, 2, 1. So at least that bit's simple. You know, with that, you don't really have to remember, the process or even the sequence. They've just numbered it. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5 for the for opening. But there it is. There it is. AEI changed that panel for the NG, and this is what it looks like. So again, it reflects changes in the door mechanism. For instance, a single vent door. It's also, I would say, simplified than the panel on the Classic. For the AEI, the power is a standalone hydraulic system, and this photo is taken in the supernumerary area. The power for that hydraulic pump is from the battery bus or a manual hand pump as a backup, and you can see the place where the hand pump lever would go at the bottom of that photo. The controls are on the 9G barrier there, which you can see. Pemco say, of course, that their modification, which uses the B system, results in the most reliable system and elimination of costly independent pump overhaul. So there you go. That's Pemco's take on it versus AEI's. You pays your money, you takes your choice. They're both very good systems, and obviously each converter is going to try and say that their system's better than the other. I personally I cannot see why one is any better than the other or not. I'm completely agnostic about it all. This is the AEI one again with that hydraulic panel open, so you got a better look at the components in there. The thing at the top looks like a toilet system. That's your hydraulic tank with a sight gauge on it. You've got various check valves, relief valves, manual selector valves to there, but I think the main thing to see there is the electric hydraulic pump, which comes off the battery bus. And at the bottom is the hand pump if you can't get electric power. The BCF panel, it's obviously different layout yet again. Main difference here is that the open close switches, you've got canopy and full open position switches rather than the single close open close switch. I'm not sure why the others don't have that, but this is just the direction that Boeing went. You can bet that Boeing had a very good look at the other three converters before coming up with this arrangement. So I mean, yeah, certainly it looks more simple, and it seems to have that little bit more functionality in giving switches, to the option to go up or down to canopy and then up or down to full open. There's a motor control valve, which you can see here, which is just on the right hand side after the wheel well in that inset photo. That gives hydraulic power to open and close the door for normal and manual operation. As I say, it's located in the lower right aft wing body fairing, in the same area as the standby hydraulic pump and brake accumulator. If it needs to be opened manually, the valve must first be moved to the open position, which is shown there. And if AC electrical power is not available, so again this would be the no APU, no ground power case. To pressurise the ACE system, you get back into the wheel well and use the hand pump. But it still looks simpler than that. Was it the Pemco system with all the various valve levers? And finally, IAI's panel. Yet another different layout. It's located just after the left forward entry door, mounted on the fuselage. There it is. So it's where the stairs. Or the air stairs panel usually is. Again, it's straightforward in that you've only got one. You've got an arm button, and then you've got an open close button there. I guess it would just be confusing, if you were operating a mixed fleet, because there's at least 4 different panels here. So if you've got a mixed fleet of them, it just requires a little bit of care and attention, to understand exactly what it's telling you, and what it might be telling you if it goes wrong. Now the main cargo door has got wind limits, because it's a huge thing to catch the wind. These wind limits are different for, again, almost every conversion. And they are also different between classics and NGs. Just to give you some examples, and this is not an exhaustive list, but the Pemco classics that you can see there, the main cargo door can be opened in any position in wind gusts up to 60 knots, only if the aircraft is pointed into the wind plus or minus 5 degrees and both actuators are operational. Well, how you can guarantee you would be within 5 degrees of the wind in gusts up to 60 knots, I don't know. Practically, I don't think that is achievable. The main cargo door may be open to the sail position, which is between 80 to 135 degrees, in wind gusts of up to 30 knots from either side of the fuselage only, if both actuators are operational. And trust me, there's more to this list, which I've abbreviated just to give you a flavour of what it is. The AEI 800 says do not open the main cargo door in wind speeds exceeding 45 knots. Boeing with the BCF say do not operate or let the main cargo door stay open at or above the canopy position in winds more than 40 knots. So again, it's the problems of flying a mixed fleet. And this is stuff that as crew, the rest of it, maybe the handlers would know, but really as crew, we've got to be on top of this, because we're going to be the guys providing the ground handlers with the wind information. So I guess tying it into the to the wind limits is, why are there wind limits, and what has been done to increase these wind limits, because the wind limits can be quite limiting, and no STC or no converter wants to have the most restrictive wind limits, otherwise nobody's going to go and get their conversions done with them. like everything, when you're choosing, a new car, a new aircraft, or new whatever it is, you look through all the specs, and you just compare, like with like as best you can. So the the people who do the conversions actually strengthen the area around the main cargo door, and really that this is done for two reasons. One is because that's the area that's going to get a lot of impact damage as the bins are moved on and off the aircraft. They will, sure as God made little green apples, they will slam into the side of the aircraft, no question about it. The other reason is the one I was talking about before, which is the wind speed limit. If you've got, gusting 60 knots of wind, and that door's open, the wind is going to catch that, and it is going to put a real strain on the hinges and the mechanism and the rams which are holding that door open. And even if the rams and the piston do hold, what it's holding to is the structure of the aircraft. And you could have a case where the door and the rams are absolutely fine and intact, but it just rips away from the aircraft because the door surround wasn't strong enough. So that's what this process is, and this is a great photo because it shows the area which has been modified in green. So during the conversion process, the old aircraft skin is actually cut out and binned, and it's replaced with a new thicker skin, which is shown here in primer in green. That new skin is roll or stretch form to match the contour, so that it matches exactly the aircraft shape. The skin attachments are back drilled from the inside using existing hole locations to eliminate double drilled hole issues. So you're not putting any more holes in the in the frame of the aircraft than necessary. There are also corner and threshold doublers at the high stress locations, which you can just about again see in this photo. This is this is a diagram here showing this is by AEI, and the coloured area here are the areas which are reinforced. So the blue areas, the areas shaded blue are the skin. So that's the replaced skin, and the frames in green and the stringers in red that have been replaced for strengthening are shown. So you can see here, it gives you a real good idea of what's been done to strengthen the aircraft. The responsibility for maintaining the any areas which have been changed by the STC provider, so AEI, Pemco, IAI, are with that STC provider. The rest of the aircraft remains supported by Boeing. Obviously on a BCF, Boeing have got the whole lot, and the STC providers say that the conversion doesn't affect the limit of validity of 100,000 cycles or 150,000 hours for the NG. So it does not interfere with the maximum life of the aircraft. And I guess that comes with their guarantees. Okay, so on to flight deck differences now. First off, the captain's DV window. On many, but not all, cargo 737s, the captain's DV window, in addition to the FO's DV window, can be opened from the outside. This was on a 200C, so obviously that's an original Boeing. It's also the same on the 700s, the 700Cs. Again the original Boeing ones. I think it's true also of the BCFs as well. I know not all of them have this, but most of them do. The logic for this modification is that following an accident, access to the flight deck from the cabin could be impossible because of a shift in the main deck cargo, so external access had to be assured. Now, obviously, yes, we know there's a 9G barrier there, but I guess they're thinking just, belt and braces. If it all moved, then we've got to give the guys a way out, an immediate way out. Now the FO's all right because but if the rescue services, say the aircraft had rolled onto the FO side, then the rescue services could only get in to release the pilots through that captain's DV window. I mean, there are break-in areas as well, up in the crown of the flight deck, but really that's the preferred way of doing it. This is excuse me, this flight deck door handle. It's an optional modification which I've only seen on classics, to allow the FO to open the flight deck door while seated, and it's a mechanical rather than the usual electric system. Again, I've only seen this on freighters, so it's not particularly common, but it's there. It just, well, as it says on the placard, turn and pull handle to manually release the cockpit door. Recirc fans. Now, this is the panel on the BCF. Boeing have obviously got a head start on everybody else because they're the original equipment manufacturer. You don't have recirc fans fitted to the 800 BCF. That's because there are no passengers, so the extra flow rate of the fans is not needed. The pneumatic panel still has the switches. That's just for parts commonality, but they're deactivated and are either placarded in op or here on this BCF version. It's all neatly done with with a proper Boeing placard. I don't think that's quite as let's say professionally done on the third party STC conversion. Now, again on the BCF, the forward cabin and aft cabin temperature zones, they serve slightly different areas to what they do on a regular 800. On the BCF, the forward cabin is purely for the supernumerary area, and the aft cabin is the whole main cargo deck. The labels on the aircon panel are still the same, so that this photo is actually of a BCF, but you see it's still labelled forward cabin and aft cabin, but obviously where it serves are the supernumerary area and the main cargo deck. The supernumerary area has got a large air distribution cabinet, which you can see in that bottom right photo, and that's got Gasper fans and a temperature sensor on it. In the main cargo deck, there are several ceiling mounted air outlets up on the center, up at the crown of the cabin, and a single temperature sensor, which you can see there in the photo bottom left. The IFA passenger seat switch, well, as all of the cabin fittings are removed, that's deactivated, and that should be placarded in op. The cabin utility switch is still there because the forward galley is still functional. The door panel. Original Boeing manufactured 737-200C and 700C, all converted BCFs, have got a main cargo door annunciator on the doors panel. So there you go. There's a benefit from having a BCF. You've actually got a proper main cargo door annunciator. The 800 BCF, it actually uses the same door panel as the 700C. Note the in-op stickers. Whilst there are 4 of them, they're only covering 2 lights. There are 4 because there are 4 overwing exit. There are only 2 lights because this is the same panel as was used on a 700C. There's no point making a whole new panel for the 800 BCF just to in-op for overwing exit captions. So this, I mean, it's a bit of an anomaly, a bit of a curiosity, but that's why you've got the double in-op stickers there, as well as the fact that they cover all the light there. Surprisingly, the aft entry and service doors are not placarded in-op, despite being deactivated. Again, I haven't quite got my head around the logic of why that is. But they are deactivated. I showed you an earlier slide. They've actually got straps across the external door opening handles, and inside you can't even see the doors because because they're all covered. So secondary gear down indicators. This is what you get on the classics. They've got the secondary indications on the aft over panel because the main gear downlock viewer is inaccessible in flight because of the cargo pallets. Now these lights are not just repeaters of the main lights, they're actually on a separate independent system, and they're not there on the NG because the NG's already got two independent gear indication systems processed by the PSEU. So this kind of makes the classic gear indicator into almost like a hybrid NG system, but without PSEU. On the Pemco classics, the secondary main gear downlock indications are on the landing gear panel there. They're only, if you notice, for the main gear, not for the nose gear, because the nose gear is still accessible, in the flight deck, or the nose gear viewer, I should say, is still accessible. For any classic conversion, if either the primary or secondary indications fail, dispatch is allowed under the MEL only if the viewport can be accessed in flight. Now on the classic, that means you can only carry 4 or 5 ULDs out of a possible 9 or 10, which makes you very unpopular with the customer. So really the aircraft would kind of effectively be grounded for cargo operations. For AEI conversions, the secondary main gear downlock viewers are up there on the aft overhead panel, just above and behind the IRS displays. So again, the hazards of a mixed fleet, you get into the flight deck and it's hunt the gear indicator, the secondary gear indicators. They can be anywhere. And similarly with the main cargo door warning panels or annunciators, they are all over the place. On the photos there are showing AEI at the top, and the bottom two are different versions of Pemcos. So the exact look and layout, as I say, depends on who did the conversion and when, because those bottom two are both Pemcos. They're usually wired in parallel with the takeoff config warning system, so it'll trigger the takeoff config warning horn if the light illuminates during the takeoff roll. If either system light illuminates, then the door isn't safe, and you can push to test all of these to just test the annunciators. With AEI, there's a cargo door armed annunciator in the flight deck, so that this isn't open, this is armed, and that illuminates any time the cargo door there's power to the master control switch on the box. So if you lift that guarded switch, that cargo door armed light will come on, and that's located above the M1 gauges. Heater pads. Okay, now Pemco QC conversions have got 4 heater pads on the inside and bottom of the main cargo door, and these aren't on regular freighters, they're only on the quick change, and that's because, or the convertibles, that's because they are also used for passenger operations as well. And now if you're on a longish flight as a passenger and you're sat next to the main cargo door, it's not insulated anything like as fully as the rest of the aircraft, and as the aircraft cold soaks in the cruise, it will freeze. It will get very, very cold there. So as a passenger comfort, you got cargo door heat pads, which are here in the flight deck on this switch. You just put them on and forget them. They're thermostatically controlled to operate between 18 and 32 degrees C. All right, a word about fire and smoke protection, because this is quite a big issue with cargo aircraft. Because you're carrying stuff which you don't usually carry on passenger flights, and the accessibility is also an issue. So there are various different classes of cargo compartments from A to F. The ones that we need to know about on the 737 are C, D and E. Lower cargo holds are Class C or Class D, and the main cargo deck is always Class E. Class E being cargo aircraft only, for the carriage of cargo. The difference between C and D is whether it's got fire detection or not. So, lower cargo compartments on all originals and classics, up to line number 3078, and NGs up to line number 90. So it's almost all NGs, and those dates around about late 1998 were actually made as Class D. Post 1998, all lower cargo compartments have had to be converted to, had to be made as or converted to Class C or Class E compartments by installing a smoke detection system, a fire suppression system, or both, which makes it Class C, depending on whether the aircraft is in a passenger or freighter configuration. The 737 NGC and QC new build cargo versions and all cargo conversions since 2001 have got Class C lower cargo compartments and Class E main deck compartments. So everything's all good. Class D is a sort of thing of the past now. The detailed specifications are there, and basically it's about fire detection, smoke penetration, passive protection and built-in fire extinguishing. And in column 3 it shows the lower hold, whether it was required for Class D or Class C. So all of the smoke and fire systems for the main cargo decks, they're actually different for each type of conversion. Surprise, surprise. Everything else has been different, and this is no different. Operationally, one of the biggest differences between the cargo and passenger flights is that once the load is in and you're in flight, most of the aircraft's inaccessible. As you can see from this picture here, you certainly can't get down the sides, and you'd have to be quite gymnastic to get across the top. And if you could, there'd be a limited amount that you could do, to be honest. So most of the aircraft's inaccessible, and with fire and smoke there's very little scope to find the source of the fire and see whether it's a real or a false alarm. So really they all have to be treated as real. And all attempts at containing the fire are from the flight deck. It's not like a passenger aircraft where you've got lots of cabin crew who can find a source of fire or smoke and use the crash axe to peel open the wall bits to get at it and firefight it with handheld extinguishers. That just cannot happen on a cargo aircraft, even with couriers or supernumeraries. So the primary method of firefighting a fire on the main deck is to starve the fire of oxygen by depressurizing the aircraft and then maintaining an altitude that will not support combustion. That's how it's done. And I'll come on to the technique of doing that on the operational things later on. But just staying with the smoke detection at the moment, all freighters must be capable of detecting smoke in the main deck within 1 minute. That's by regulation. That's why there are so many smoke detectors. Multiple smoke detectors in the ceiling, precise number of detectors anywhere between 10 and 14 depending on the model of the aircraft. For Pemco Classics, the smoke detectors look like this. Or the smoke detector panel in the flight deck looks like this. So this was an early one. I mean, crikey, I flew this aircraft maybe 15 years ago. You've got 10 sniffer ports, 5 in the ceiling, which are the top row labelled C, and 5 along the sides of the cabin labelled S for side. Air from the sniffer ports, it's then ducted to smoke detectors and then dumped overboard through static ports in the bottom skin of the fuselage. That on-off switch at the bottom is to switch the system on or off passenger operations. So for passenger operations, you'd have it off, as per this photo. If you're flying freight, then you would have it on, and all of those 10 sniffer ports will be active. AI took a different approach and put all of their smoke detectors in the ceiling. Logic being that smoke rises, so side detectors were of a limited value. I mean, again, there's arguments for and against this. I mean, if the fires or the smoke is starting from the bottom of a pallet, it's probably going to pass a side before it passes a ceiling. But you know, who knows? Anyway. AI went this direction and put them all in the ceiling. There are 12 detectors in a row from the front to the back. This improved the detection time to under a minute as required by legislation. It also enabled crew to locate the source of smoke with more certainty. But again, firefighting is impossible, so knowing where the source of the smoke is of kind of limited value. With AEI Classics again, if smoke's detected, you can have a main cargo smoke light, one on each side of the instrument panel. This on the captain's side, under the captain's clock there. These lights also have a push to test facility, so you can push them in and test them to see if they work, and a push to test on the actual panel itself. Below the smoke detection panel, you've got a cabin air shut-off switch, guarded switch, and this shuts off air from the mixed manifold to the cabin for smoke emergencies. When the cabin air shut off, the amber light to the left there will illuminate. When that's done, important to note, although the air to the cabin is shut off, the air to the flight deck still flows. So there isn't necessarily a need to go on oxygen. You will still have air in the flight deck. Procedures may and usually will dictate that you do, but it isn't necessary. For AEI NGs, the panel looks like this. This is located on the electronics panel, whereas with the Classics it was on the overhead panel. Functionality is the same, but it's got 2 more smoke detection zones and an A and B detector test facility rather than a single push to test button. So you've got 2 loops on this. The cabin air shutoff function is the same, but it's now labelled cargo compartment air shutoff, which is a bit more logical than cabin air shutoff. I think. I mean, it just points more to, you know, or suggests more that it is only the cargo compartment that you're shutting air off to, and not the flight deck. For BCF, for the Boeing converter freighters, this is the panel. Now, the panel which looks most similar to the ones that you've seen before is the cargo electronic unit, and that actually isn't in the flight deck. That's in the that's in the cargo hold. There are 3 of these, 1 in each cargo hold, and a 3rd one for the main deck. This is what sends the signals to the cargo fire panel in the flight deck. Each of the 3 panels activating either the forward, aft, or the main deck smoke detection system. The flight deck cargo fire panel is therefore much more simple compared to other conversions. And you know, it keeps the same look and layout as the existing passenger cargo fire panel. So you know, it's much more familiar and intuitive to us as pilots. Um, just be aware that there are no fire extinguishers for a main cargo deck fire on any type of conversion at all. It's all done by removing the oxygen from the fire and getting down as soon as possible. Pressing the depressurization discharge button has got the same effect as the cabin air shutoff switch on other conversions. So this button does the same thing as the other ones. It shuts off the air from the mixed manifold to the cabin, again not to the flight deck for smoke emergencies. It also opens the mixed manifold exhaust shutoff valve to vent most of the mixed manifold air overboard, thereby reducing pressure in the mixed manifold. Because if it hasn't got anywhere to go to, then it can overpressure. So it vents it overboard. Again, be aware that there are no fire extinguishers for a main cargo deck fire. Can't stress that enough on any conversion of any type of 737. All right, so let's have a look at the in more detail the air system functions on the BCF. So starting with the left, if you push the main deck cargo fire arm switch, that does certain things. It energizes the forward and aft main deck shutoff valves and the mixed manifold shutoff valve, but it doesn't change their positions. It just energizes them, because remember that this is arming. It's not activating or firing, it's arming. So it energizes the solenoids for the valves, though, so it puts them on a state of readiness, ready to be operated. It also reconfigures the aircon system to low flow mode as well, because you only need low flow because you've only got air to the flight deck, not to the not to the main cargo area anymore. Now the depressurization discharge switch. So if you push that actually closes the forward and aft main deck shutoff valve, stopping airflow to the main deck, but keeps airflow to the flight deck, and that delta P will also stop smoke, or help stop smoke entering the flight deck. Note that the lack of air going into the cabin will only cause a gradual depressurization up to about 1500 feet a minute. And again, I've done hundreds of test flights on aircraft where we take them up to ceiling and we switch off both packs. The aircraft has a natural leak rate that they call it, where air gradually dissipates out of the cabin, but the limit of that leak rate is 1500 feet per minute. So that's what you can expect to see in a serviceable aircraft. So don't think that by shutting off the air you're going to suddenly rapidly depressurize the aircraft and it's going to be uncomfortable and dramatic. It won't be, but 1500 feet a minute, it's 3 times or over 3 times, depending what fit you've got, what you would normally get. So you'll probably feel it on your ears. Note that the outflow valve must still be manually opened as directed by the QRH. Pressing this switch does not have any effect on the outflow valve. You've still got to follow the QRH instructions for that. This will then depressurize the aircraft quickly, reducing the amount of oxygen available to the fire. So again, just pressing that switch, you get the gradual depressurization, 1500 feet per minute. If you follow it up by QRH instruction by opening the outflow valve, then you can get really high rates of depressurization. You 2, 3, 4,000 feet per minute, whatever you can physiologically stand. The depressurization button also opens the mixed manifold shutoff valve, thereby reducing pressure in the mixed manifold. So it just cuts off the air before the mixed manifold. So lots of functions there on the BCF fire panel. Other end of the spectrum, you got the 200, the original cargo 200s. So these were again the ones built by Boeing. They had a cabin air shutoff feature, which allowed the crew to pressurize or unpressurize the passenger compartments. Again, not the flight deck for smoke clearance. So I think that's shown you on every generation of cargo 737. We've also got door seals on the flight deck, which you don't see on passenger aircraft. This rubber seal along the bottom edge, that acts as a smoke barrier, just by closing off the space between the bottom of the door and the floor, preventing smoke from passing through to the cockpit. Again, I'll just say this again: the 9G rigid barrier is the main smoke barrier when the door is closed, obviously. But say, for instance, the fire was in the supernumerary area, I can't think why it would be, or the smoke had breached the 9G rigid barrier. Then this, it's just something that could help. All right, a quick word on horse freighters. These are obviously special types of cargo aircraft, and this photo shows a 737-300 that was converted to cargo in 2008 by Pemco, and it's primarily used for the transport of horses. Now, because of the high number of supernumeraries, grooms and vets required for horse transportation, because obviously there's more than one horse flying on the jet, you need a lot of grooms. The usual, 4 or 5 seat supernumerary area at the front of the aircraft, just, there wouldn't be enough seats. So this aircraft, this particular one, has got 11 seats at the back of the cabin behind the freight area, similar to a combi. So it's a kind of a combi freighter, horse freighter. It's not for pure passenger, true passenger use. They are sort of supernumeraries. Inside, that's what it looks like with horses on board and handlers doing their work. The mats are down there to partially to so that the horses don't catch themselves, in the mechanism, the roller mechanism, but also, if the horses, urinate or make some muck, it can be cleaned up, quickly without it getting into the mechanism. Inside the flight deck, this is the only difference. You've actually got a roll change control panel. In horse config, the main deck smoke detectors are switched off, and that prevents steam coming off the horses from setting off nuisance warnings. I mean, I don't know how much you know about horses, but certainly if you've ever seen horses when they get excited, when they and obviously it is quite an exciting experience for them to go on a flight. It's all new and strange. What they do is as they get nervous and so they can sweat, and trust me, a horse can sweat a lot, and you can physically see the steam coming off them. And if you've got half a dozen horses on board, that is going to set off the smoke detectors. Together with any other emissions the horses might make. So that's what the roll change button does there. There actually isn't a lower caption on that guarded switch. It's just blank when the aircraft is in normal freight config. And the cabin altitude test button, it just tests the cabin altitude warning in the cabin for the horse handlers. The horses can either be walked up a ramp or lifted on by a scissor lift in the pallet. It depends what facilities the airport's got and how obedient, shall we say, that the horse is. Some horses can be difficult to load. Some don't mind going up there. But it's all in the hands of the handler. All right, let's have a look at loading and weight and balance. Generally, on the classics, you always carry ballast, and you always carry ballast because you often need ballast. If you're ever ferrying empty, or you've only got small amounts of cargo, you will need the ballast. And the reason for that is because of the weight distribution of an empty cargo aircraft versus a passenger cargo aircraft. With an empty one, they are very nose heavy, and that is because of the weight of the strengthened, as you've already seen, main cargo door, and the mechanism and weights for that, and also the weight of the 9G bulkhead. So those things combined make all freighters relatively nose heavy compared to passenger aircraft. Now, when they've got cargo, it's not a problem. You know, the loadmaster, you know, or your load control will take care of it, and will balance the load of the cargo, you know, in the pallet positions accordingly. But if you're empty, there's no load to balance, and that's why you need the ballast. 300s need around 800 kilos, 800 to a ton of ballast to fly empty at the back, and the 400s need more than that, usually 12 to 1800 kilos. 1800 you can see I've got in this example one here. The 800 BCF, which is the only one I'm familiar with of the NGs, that doesn't need any ballast to fly empty, as the empty Mach is up between about 6 and 8%. So it's not too bad. It doesn't need ballast. But you can see in those Mach figures there that the classics do. Talking of loading, misloading is a big risk. A common error, until spotted, is to load the aircraft back to front from the load plan. Now, that could lead to a tail tip during loading or unloading, or a tail strike on takeoff, or put the aircraft dangerously out of CAG limits in flight, which if you had if you got into a stall, or possibly engine failure after takeoff, low speed, it could make the aircraft unmanageable, leading to a loss of control. So many cargo operators monitor the loading process with at least 2 people, sometimes 3, to ensure that the aircraft is loaded correctly. It's really bad juju if a cargo aircraft is misloaded. The other threat with loads is a load shift, and that can put the aircraft instantly and dangerously out of trim. A forward load shift shouldn't breach the 9G barrier, but that's not to say we want to try it. Now, there are several procedures in place to help prevent load shifts. Starting at the load planning stage, the safest scenario is to have every bay on the cargo deck loaded with a container. That way they just don't have the room to move. Some customers do this as a matter of course, even if it means carrying empty containers, so that removes any possibility of a load shift, but sometimes it just isn't possible or practical. Where there are void bays, empty bays, without a bin, then it's best if the aircraft can be loaded so that the voids are toward the front of the aircraft. That enables the location of those bays to be visually checked when loading to complete against the load plan. But again, this is all in the hands of company procedures and handling agents' procedures. Now, sometimes the risk with a load shift is not an out of balance condition, but the damage that the loose load can do. Now, we know that there's a 9G bulkhead at the front, but there's also a rear bulkhead at the back, and this photograph from an NTSB report it was a 737-300 in 2014, shows a stack of cargo. They're called cookie sheets. They're basically collapsed bins, which are flattened to transport them when they're not used. These weren't secured properly, and they shifted rearwards on takeoff, causing substantial damage to the aft pressure bulkhead, such that the aircraft was not able to pressurize. Now, the crew didn't notice anything out of the ordinary. They didn't feel the load shift because obviously it's not a big weight. They probably didn't hear it because it was right down at the back of the aircraft, and you know, there could have been other stuff, you know, in between that and them. So they didn't feel anything. They didn't hear anything. The first thing they knew about it was when the pressurization auto fail light came on during the climb. And then on reaching 10,000 feet, the altitude alert horn sounded. As always, I've included a copy of the or a screenshot at the top of the report there. If you want to go look at it, those of you flying cargo, it's probably well worth doing so. You can just Google that and find it. Okay, so this is another event which is peculiar to cargo aircraft. Very recent one as well. Less than 2 weeks ago, a 737-400F was being ferry flown with payload ballast in the aftmost position in the main cargo hold. As already mentioned a few slides ago, the 737-400F needs around about 1.5 tons of ballast right at the back to stay within CFG limits because of the weight of the cargo door and the 9G rigid barrier. Anyway, according to the initial report published by the BEA, which you can see on the right hand side there, and this is just taken from the I believe the report filed by the crew. They said that during descent towards Paris Charles de Gaulle there was a huge bang that shook the entire aircraft, producing a strong yaw and destabilizing the flight path. Investigation by the flight crew indicated that the payload ballast had moved from the aftmost position in the main cargo hold toward the 9G forward barrier in the forwardmost position of the main cargo hold. During both flap and landing gear extension, the loose ballast moved again and slammed against the 9G wall. So again, another example of how not only must, you know, cargo be secured, but ballast as well, if it's carried, must be secured. Arguably, ballast can do, you know, possibly more damage than cargo because whilst there's less weight of it on an empty aircraft, it can travel the full length of the aircraft, building up speed and momentum before slamming into the 9G barrier. Anyway, a preliminary report suggested that the 9G barrier was not breached, which is good. So there you go. It's been combat proven. Now, other causes of tail tipping is mismanagement of the loading or unloading, and it can be either. The most famous recent case was in late September 2021, which is the photo at the bottom there of a United 737-900ER, which was carrying a USC football team, and that tipped during disembarkation. Now, the report isn't out yet. I don't know if it will be, but what you can see from the photo is that the baggage has been offloaded from the front hold, and disembarkation is through the front door. So it's probable that as the passengers disembarked from the front of the aircraft, that caused the CAG to move aft, and the tail tip occurred. The upper photo is that's at Malaga by the looks of it, and I forget the details of that one, but again it's on stand, so it's obviously going to be a loading incident. Now, those two events were with both with passenger aircraft, but you know, one was an 800, one was a 900. It is possible for even the short-bodied ones, you know, a 300's tail tip. And this is a photo of an event that occurred in 2017. Now, again, there's been no official report published on this, but according to statements from those in authority at the time, what happened was, during the unloading process, cooking oil in the centre of the cabin spilled out, causing the floor to become slippery. This caused the rest of the cargo to slide to the rear and led to the tail tipping. Now, I must admit, I'm struggling to visualize how a spillage of cooking oil can have caused the rest of the cargo to slide to the rear. But anyway, that's what they said happened. Who do we know? But you know, a picture speaks 1,000 words. Whatever happened, it was carrying cooking oil, and whatever happened, it tail tipped, and it is a 300. So don't think you're immune to it just because you're flying a short body aircraft. You know, take care out there. Another mitigation for tail tipping is loading poles. These are more common in cargo operations than in passenger operations, but some operators do use these routinely, particularly in the longer bodied aircraft. So usually without loading poles, what you would normally do is you would stagger the loading and the unloading of the aircraft. So you do the forward belly holes would be loaded first, or you put a ULD in the most forward position. Then you would move the next one aft, or keep it in an intermediate position until the next ULD is being loaded on the aircraft. Only then would you move that one after its final position, and so on and so forth. It's sort of easier to visualize than to put into words. If the loading and unloading is done carefully, loading poles shouldn't be required, but yeah, they're a good insurance policy. The only thing there is, of course, you're introducing a new risk, which is forgetting to remove them after use. So that could get embarrassing on pushback if that's still in place. Okay, these photos here show damage as a result of another unintended consequence of using loading poles. Shortly after loading, the carriage of loading poles was mandated by an airline that shall remain nameless. That what was done was the loading poles were simply placed in the in one of the holds. Unfortunately, they weren't secured when they were placed in there. So, of course, on takeoff or landing, they became projectiles, and the pointy end, as you can see there, impelled its way through the bulkhead and out through into the wheel well, narrowly missing a hydraulic cable, but nevertheless causing enough damage to ground the aircraft for a while. I believe 2 aircraft were affected on the same day, on the first day of the SOP to carry the loading poles. So yeah, unintended consequences. A lesson there in all aspects of aviation. If you're going to introduce a new SOP, then think it through and run it past some SMEs first. Okay, final sections on the operation and documentation. And again, any of you watching this who aren't or who isn't a freighter pilot, this will be new to you. So in the flight crew training manual, there is an expedited descent for freighter airplanes manoeuvre, and basically this requires an immediate descent to flight level 250, which is then maintained for as long as practical. What it does is it minimises the oxygen available to the fire while accommodating flight crew physiological needs for extended flight on supplementary oxygen. And in the text there it says it's a separate and different manoeuvre from the rapid descent. So this is not to be confused with the rapid descent. That's what regular 737 pilots know about, in a decompression. The rapid descent is designed to bring the aircraft down smoothly to a safe altitude. The expedited descent is designed to maintain flight level 250 for as long as possible. Descent from flight level 250 is only started when expedited or uninterrupted descent to the lowest safe altitude of 3,000 feet can be accomplished. What it does, it shortens the flight time below flight level 250 to minimise the severity of the fire in an oxygen-rich environment. Intermediate level-offs are avoided. So let me just take you through that. This is the profile straight from the FCTM. So they are at 35,000 feet or whatever in the cruise, and fire is discovered. Smoke detectors go off, or the supernumeraries tell you, oi, Chris, we got a fire. First thing you do, as always, the immediate actions: masks on, goggles on. Close the flight deck door if it isn't already done so. Establish communications, and then go for the QRH. Action that. Get the descent going down to flight level 250 as soon as you can. Obviously, the aircraft will be depressurizing as a result of the QRH actions. That will be starving the fire of oxygen. At flight level 250, you level off and you maintain that until you're 50 miles from your diversion field from the runway. At 50 miles, extend the speed brake and descend at VMO to 3,000 feet or MSA if higher. At 3,000 feet, retract the speed brake but continue at VMO. So this is this is quite punchy stuff, being VMO at 3,000 feet, and you maintain that until you're just 15 miles out. 15 miles out, slow to approach speed, using the speed brake as required. I mean, obviously, chuck everything out, get the thing slowing down. When on the glide, extend the flap and gear on schedule, and down you go. I say this is Boeing's expedited descent maneuver. It's the way to get you down as quickly as possible, or down to flight level 250, where you can stay on oxygen, and then as expedited as approach as you can. It is quite a punchy maneuver, this, as I say. Being VMO to 15 miles out is something we obviously don't ordinarily do. Where obviously most of us fly for airlines where the emphasis is on a stable approach. Clearly, in a non-normal stroke emergency situation, that is replaced by this maneuver, which I should emphasize, freighter pilots are trained to do this. They practice this in the sim. They're used to doing it. I mean, if one of us passenger boys were to come and have a go at this, I'm sure we'd make a holy mess of it first time round. So let's those of us not flying freighters, don't try and put this in your repertoire unless you've been trained for it. Leave it to those guys. The other operational emergency, I guess, peculiar to freighters, is the main cargo door opening in flight. Now, there have been cases of this. The last one was in August 2021, a 200C in Colombia, which completed a very nice circuit and made a successful landing. I did a video on this a couple of years ago on side cargo door open, if you want to see it, and in there you have a quick reminder of the system and the operational procedures involved. I'm not going to repeat it here because it was all covered in that video. All right. So to finish off, let's just have a look at the documentation differences. So as regards the AFM, aircraft converted into freighters have got differences, like significant differences. I mean, remember that slide from AAI, all those different changes that were made to aircraft during the conversion process. So they've all got differences from the original Boeing built version. Those differences are all documented in a supplement to the aircraft flight manual. That supplements or supersedes the information in the basic AFM. And there's a similar document for the AMM, the maintenance manual, and also for, as I say, wiring diagram and all of the other manuals. This supplement contains information such as any new aircraft limitations, for example, main cargo door operation, wind limits and those sort of things. Also modified system descriptions. So again, the hydraulic system, smoke detection, that kind of thing. And any new modified, normal, non-normal and emergency procedures, such as the ones we've been talking about, the main cargo door open in flight, or the smoke procedure. The information in the AFM is reproduced in the FCOM and the QRH in a format more familiar to us on the line as line pilots. I mean, most line pilots have not actually seen an AFM, and it is quite a dry old document. What we get is the pilot-friendly version, which is the FCOM, and of course the QRH. So with this QRH, which you can see in the photo there, this is a QRH supplement, and it's an AAI QRH supplement. So examples of new emergency procedures associated with the equipment included with the conversion could include things like main cargo door warning, cargo smoke warning, or main landing gear indicators unsafe. Because these procedures were developed by the third party that did the conversion of the aircraft, i.e. not Boeing, the procedures can't be integrated into the main body of the QRH. Instead, they're contained in a QRH supplement at the front. So you've got to know of the supplement's existence. You've got to, again, these are the hazards of flying mixed fleet aircraft. If you're flying a Pemco, an IAI, an IAI, classics and NGs, these procedures will be different. They will be all over the place. So good airmanship, you get in your aircraft, you work out which one you're on, where all the differences are, and how different the QRH is. It's a lot easier doing that before you go flying than when you're up there with the main deck on fire. Now, many operators have got QRH procedures which are integrated into the QRH. These are obviously far more desirable than the non-integrated. Third-party conversion procedures are marked with those sort of brackets after the title and have got dots in the margin to indicate which bits are not original Boeing. Example of that above with that's an IAI QRH extract, and the one below is a BCF QRH extract, which hasn't got any of the brackets, any of the dots. It's fully integrated. That again, I take you back to Boeing's selling procedures. One of their main selling points is that everything is fully integrated. FCOMs, like the QRHs, may have separate supplements or descriptions and procedures integrated, but they're marked with the brackets to indicate that they are third-party procedures. They've also got the dots down the sidebar, same as the QRH. Again, BCF aircraft, Boeing converted freighters, they've got fully integrated QRH, FCOM, AFM, maintenance manual, etc. No annotations, no dots, no brackets, fully integrated, and that again is one of Boeing's real big selling points. It's all seamless. That is it. That's everything I know about freighters. As always, if you've enjoyed the video, give it a like, subscribe to my channel if you haven't already done so, share the link, and if you're feeling charitable towards me, want to buy me a coffee, then purchase a copy of the book. It's available in both hard copy, paper, or electronic version for the iPad. Thanks very much for listening.